Now that we've been introduced to this idea of writing mathematical proofs, specifically with algebra, let's move towards proving geometric statements. In this lesson, we'll look at how to write a two-column proof and what that is, understand how to make statements that are based on facts and conclusions, and how to understand to write reasons, definitions, postulates, theorems, and properties that support and show evidence for each of the statements that we make. In this lesson, you'll need to know a few terms, definitions, postulates, and a few new theorems to help you with your proofs. So let's go over those now. You'll want to remember what congruence means. Remember, if two figures are congruent, it means they have the same measurement. So if we're looking at congruent segments and angles, we're saying that those two segments have the same measurements, or their measurements are the same length. And the same thing for angles. Okay? If two angles are congruent, they have the same measurement. We'll also want to remember what a midpoint is. The midpoint is that exact middle of a segment. Okay? That is basically cutting that segment in half because the two sides of it are now congruent to each other, because that midpoint is exactly in the middle. And there's other definitions that we'll want to know, like points, lines, and planes, and everything else that we've learned in that first unit with our basics of geometry. In that first unit, we also talked about the segment and addition postulates. You'll want to keep those in mind as well. Those might come in handy for some of our proofs, maybe in the next section as well. So remember, the segment addition postulate just says that the two parts of the segment, whatever the lengths of the two parts of the segment are, add up to the whole length of that segment. Okay, remember the parts add up to the whole. And the same thing for the addition postulate. The two parts, the two lengths of that angle add up to the whole length, or the whole measurement of that angle. Okay, that's the segment and addition postulate. And of course, there were other postulates that we learned in this unit in our first lesson about points and lines and planes and how they interact with each other when they intersect, okay, and what that looks like. You'll also need to keep in mind all of the properties of equality from this unit, like the addition, subtraction, multiplication, reflexive, transitive, and the distributive property. Okay, you'll want to have those ready as reasons to support each of your statements. And then in this unit, we'll also be looking at some segment and angle congruence theorems, which are really just based off of the definition of what it is for two parts, or two segments or two angles to be congruent to each other. Like in the reflexive, symmetric, and transitive properties of congruence are similar to the properties of equality, but we're talking about specifically congruence, meaning they have the same measurement. So like for the reflexive property of congruence, it says for any segment AB, that AB, the segment AB, is congruent to itself. Okay, so the segment is congruent to itself, which means it has the same length as itself. Remember that reflexive property of equality? It holds also for congruence. So you'll want to keep those in mind as well. With all of these, okay, you don't have to memorize them. That's not what we're expecting from you, but you do need to know how to use them and in what situations you would use them. And I've uploaded a document with all of these onto our Google Classroom, so you have access to it there. All right, let's analyze a simple two-column proof to kind of get an idea of what that looks like. And I know this may be hard to see on the video, but this is the same picture that is on the first page of your notes in section 2.5 or lesson 3.3. So you could look at it there as well. And we're just going to break down a couple of things that we see here to get an idea of how do we approach and understand these two-column proofs. There are multiple ways to write a proof, but for us, just at the beginning, we're going to do this two-column. It's a little bit easier structure for a lot of people to engage with, and it's a little bit more organized. That kind of helps you think through it a little more systematically. So if you'll notice in our proof, we have here a given statement. Okay? That given statement is what's given to us, right? That's the information that we start with. Okay? That's always our starting point. And often we'll have a figure that goes along with that. Okay? And so the figure and the given statement are usually telling you the same thing, but the figure gives you that visual representation that helps you understand it in a different way. And then we also have our prove statement here, okay, under our given statement, and that's what we're trying to prove. Okay? That's where we're going. So our given statement is our starting point, our prove is our ending point. Okay? And so you'll notice that in the proof, our given is what goes first, and our final statement should be what we're trying to prove, okay, what our final conclusion is. So it's kind of like a maze. The rest of it is kind of like a maze. You know where you're starting. You know you have an endpoint at some point, but you have to figure out, where do I go in between there, and how do I get there? And what do you do when you hit a wall, and or when you think you're on the right track and but you're not, and you have to go back? Like, how does that all work? So it's kind of like a maze and figuring out where you go. And your reasons, your properties, definitions, and theorems, that's your guide through the maze, telling you where you can and where you can't go. And so that's what's helping you kind of navigate these proofs, along with your diagrams and your given information. Because once you have shown something to be true, you can then use that as you move forward. So you'll notice off here to the left we have our statements. Those are the facts or conclusions that we're making based off of the information that we have. So remember, we start with our given, and then based off of that information, the fact that, in this case, the fact that these two angles are congruent to each other, what do we know? Okay? That's a common question you're going to ask yourself when doing these proofs. Based off of the information I have, what do I know from that? Or what is the next thing I can conclude from that? So in this one, you see that because these two angles are congruent, we know that their measurements are equal to each other, because that's what congruent angles are. It means they have the same measurement. And so we can make that statement, because we know these angles are congruent, then we know that their measurements are equal. We can make that statement because my reason, the definition of congruent angles. That's what congruent angles mean. It means their measurements are the same. And so you can see that for every time you make a new statement, you have to have a reason that supports that statement or shows evidence for why you can do that. Okay? And so that's the structure of these two-column proofs. Is I'm making statements one right after the other, okay? And the information before is what's informing my next line. And each statement has to have a reason that is showing, why do you think that, or why does that work, or why is that true? Okay? And so that's the general structure of these two-column proofs. So just kind of keep in mind when you're working with these, you want to understand what's given to you, okay, and what you're looking at. You have to understand what you have and what makes sense about that. And then based off of what you have, what can you conclude from that? Okay, what do you know because of that? Okay. And then finally, what reasons support those conclusions? Okay. If you're saying that those measurements are equal to each other, why do you think that? Okay, explain your thinking in that. What's your reason for saying that? In this example, we have a proof that's partially filled out with the statements and partially filled out with the reasons, and we're going to fill in those missing statements and reasons. So we first want to look at our given information. So we're told that T is the midpoint of segment SU. So if we look at this segment here, we have segment SU, and T right here is at the midpoint, the exact middle. And we want to prove that x is equal to 5. So in this situation, with this segment, we want to prove that x right here is equal to 5. So as always, we start with our given. So that's our first statement. T is the midpoint of SU. That's our given. And from there, we figure out, okay, what do I know based off of that information? So if the first statement, that T is the midpoint of segment SU, okay, if T is right in the middle, then what we know about midpoints is that they split a segment in half. Okay, and the two parts of that segment are congruent to each other. Okay, so from there, the fact that T is the midpoint of SU, we can say that ST this segment is congruent to this part of the segment, TU. And that's the definition of a midpoint. Okay? And that's how proofs work. Okay? Based off of this information, what do we know? Okay? And how do I know it? This reason right here. All right, so if I know that those two parts of the segment are congruent to each other, then what else do I know? Well, if the two parts of the segment are congruent to each other, then I know their measurements are equal. How do I know that? Because that's the definition of congruent segments. If two segments are congruent to each other, then their measurements are equal to each other. Now go to the fourth line. If I know their measurements are equal to each other, what can I say? Well, now you kind of have to figure out, where are you trying to get to? Okay? Well, you know that you're trying to prove that x is equal to 5. So what's going to get you a little bit closer to saying that x is equal to 5? Well, we probably need to say something about the x's. So if I know that ST is equal to TU, that the two parts of the segment are equal to, their measurements are equal to each other, then I can say 7x is equal to 3x plus 20. Why can I say that? Well, if I look here in my figure, ST has a measurement of 7x and TU has a measurement of 3x plus 20. So if ST is equal to TU, which I just said right here, then I know that 7x is equal to 3x plus 20. Because we know that the measurement of ST is 7x and the measurement of TU is 3x plus 20. So what's our reasoning for this? Substitution. Substitution property of equality. Because if ST is equal to TU and ST is 7x, then I'll just replace them. And if TU is 3x plus 20, I'll substitute that in. Okay? And so now instead of saying ST equals TU, I've said that their measurements, okay, what the actual measurements are, 7x and 3x plus 20, are equal to each other. Now what do I do next? Okay, so this is where we have a statement that we need to fill in. So again, I'm trying to get that x is equal to 5. Well, now I have an equation with x's. So how do I show that x is equal to 5 here? What's my next line going to be? 4x is equal to 20. Well, how do I do that? Well, that's because I subtracted, right? The subtraction property of equality. Okay? I subtract 3x from both sides and I get 4x equals 20. That's because of the subtraction property of equality. And then from there, I would get x equals to 5. How do I get that? I divided by 4. I used the division property of equality. And that shows me that x is equal to 5. And so I've proven what I wanted to prove. I took T is the midpoint of segment SU right here and shown that x is equal to 5. Okay? And these are my statements, everything that I did to show it, and then these are my reasons for all of those statements. Let's look at this other proof. In this one, we're given the measurement of angle 1 is equal to the measure of angle 3. And we want to prove that the measure of angle EBA is equal to the measure of angle CBD. So that's all in this figure here. Okay? So we know the measure of angle 1 is equal to the measure of angle 3. And we want to prove that the measure of EBA is equal to the measure of CBD. And so how do we do that? Again, we have a proof kind of partially filled out for us. We have all of the reasons, and we want to use those reasons to help us figure out these statements. Now, normally when you're proving something, if you're on your own without any supports, you have no statements, no reasons, you got to come up with it all. But since we're just learning, we're kind of filling in the statements and the reasons as we go. So as always, you start with your given information. So what is our given information here? We're told that the measure of angle 1 is equal to the measure of angle 3. Right, that's our given information starting right here. You always know where to start at least because you know what's given to you. All right, so if the measure of angle 1 is equal to the measure of angle 3, what else can we say about based off this figure or based off the given information? We know that the measure of angle EBA is equal to the measure of angle 2 plus 3. And that's based off of the angle addition postulate. Because the parts of the angle add up to the whole angle. So the measure of angle 2 plus the measure of angle 3 adds up to the whole angle EBA here. And if we know that the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 3, then we also know the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1. How do I know that? Because of the substitution property of equality. Right? If we know the measure of angle 1 is equal to the measure of angle 3, then I can replace these. So instead of the measure of angle 3, I'll say the measure of angle 1 plus the measure of angle 2 is equal to that. All right, the fourth line, the measure of angle EBA is equal to what? Well, it might be hard to figure that out since we're just kind of learning this, what goes next. But we can see our reason here. It says the commutative property of addition. Okay? Well, the commutative property of addition just means that the order doesn't matter. Okay? So instead of writing the measure of angle 2 plus the measure of angle 1, I can also write the measure of angle 1 plus the measure of angle 2. I can flip them around and everything stays the same. Okay? The commutative property of addition says that when you're adding two things, it doesn't matter what order they're coming in. Now, why is that important? Because then it becomes a little easier to see what we're going to do next. Okay? So in number 5, the statement 5, we know the measure of angle 1 plus the measure of angle 2 is equal to what? Well, if I look back in my figure here, the measure of angle 1 plus the measure of angle 2, 1 and 2, is equal to CBD. Okay, the angle addition postulate tells me the parts of the angle add up to the whole angle, so 1 and 2 would add up to CBD. The measure of angle CBD. So now I've shown that the measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2. And the measure of angle 1 plus the measure of angle 2, we know from the figure, is equal to the measure of angle CBD. And so based off of the transitive property of equality, what can I say? Well, if EBA is equal to this and CBD is equal to the same thing, then they're equal to each other. So the measure of angle EBA is equal to the measure of angle CBD. And now we've proven what we wanted to prove. Measure of angle EBA is equal to the measure of angle CBD. So that is an example of where we're having to fill in the statements based off of the reasons that are given to us. Now, it may not seem super linear logical to you right now, but that's as we're practicing, we're trying to figure out, okay, how do we make connections between statements and reasons, and how do we understand what to do next? Like, and how does one line lead to the next? And we'll continue to work with that.